Okay, let's talk about charge in an electric field region. If we have an electric field region, let's just imagine this is a charge, Q, maybe a positive charge or a negative charge. Okay, let's just say a positive charge. And we carry this positive charge and place it inside an electric field region. Let's just assume these are electric field lines. I understand, you should understand that drawing these lines this way means there is an imaginary positive charge at this place and a negative charge, because field line moves from positive to negative. So if this is an electric field region and we carry a charge and put inside this field, the charge is going to feel a particular force, F, that is called the electric force. So electric force is simply something felt whenever a charge is brought into an electric field, and the electric force has different magnitude at different points of the field. Let's just assume that the field is stronger at this point and weaker at this point. The force felt by the charge, when we carry this charge and put it somewhere here, the force felt here will be different from the force felt here. So let's talk about the calculative aspect of this subtopic. The relationship between electric field and this force can be written this way. The electric field E is equal to the force all over the magnitude of the charge we placed in that electric field. So we could also use this as a formula to find the strength of an electric field at a particular point. And what do we mean by that? Assuming this is an electric field and we want to know the strength of the electric field here, what is the strength? We simply carry an imaginary charge and put it there, and once we put it there, it's going to feel a particular force, F. So if we divide that force by the charge we brought into this place, we can find the electric field. So let's practicalize this with a particular question. Assuming we bring in, this is an electric field, E, and we want to find the electric field strength at this point. And we'll bring in a charge of 2 coulombs. Remember, the coulombs is the unit of charge. So if we bring in a charge of 2 coulombs and put it here, and these 2 coulombs felt a force of 4 Newton. Force of 4 Newton. So what would be the electric field at this point? We simply say the electric field is equal to the force all over the charge. So that will be equal to 4 Newton divided by 2 coulombs. So that will give us 2. The unit of electric field is Newton per coulomb because it's force all over charge. So this should be the first formula you should know in this subtopic, that electric field is equal to force all over charge. This could be asked in your test or exams, but just with practice, you will remember this formula anywhere, anytime. So, but I want you to remember that whenever you are asked a question in physics, in photophysics, like electric field related question, the question is always related to field, force, and charge. So they might give you charge and force and tell you to find field. They might give you field and force and tell you to find charge. Let me give you an example. Assuming they say in a field region of 20 Newton per coulomb and a force is felt by a particular charge of 10 Newton or of 10 coulomb. In a field of 20 Newton per coulomb, a force is felt by a charge of 10 coulombs when placed in that particular field region. Find the force. So the field is not always what they want you to find. you could be finding the force, you could be finding the charge, you could be finding the field. So what you just need to do is make subject of formula what you are looking for. So we are looking for the force here. So we'll say the force should be equal to QE, the charge multiplied by the field, which will give us 10 multiplied by 20. Americans will say it's 20. So this should give us 200 Newton. So that should be the force felt by this charge when placed in that field. So this is what we need to know about a charge inside a field region.